All right, so we have talked about slopes before, but we're going to get a little bit more into it. This should be pretty easy. It should be stuff that you've seen before. It's nothing brand new. It's just a little bit of review. I'll do a couple of the problems with you before we get out of here today. And that's it. So let's talk about the word slope, first of all. We've talked about this before. We even had that little story. Do you remember the story about no slope? What was the story about no slope or undefined slope? What was the story I told you in class about me personally? Anybody remember that at all? ROTC. Right, the ROTC thing. I was repelling, right, and all that kind of stuff. So, being so difficult, just put the power inside the trash. You done? All right, can we continue? Sure. So we've talked about slopes before, but we're just going to get maybe a little bit more into it. We did it with an equation of a line, and we're going to put an equation of a line here at the end, but right now we're just going to talk about slopes. What letter do we use to represent a slope? M. We use M to represent a slope. Don't really know why. Actually, people don't even know where the originated. We talked about that before, but we use the letter M, all right? And there's one little thing that people remember all the time. What's the one thing that you remember that something over something is the slope? Rise over run. Yep, everybody remembers that one. Okay, they both start with R. It's just real simple, real easy. It's the rise over the run. But I'm going to show you something else. Here's something that they do when you get a little bit beyond just Algebra 1. All right? They say the rise, like if I was to rise like from here to here, all right, it's the change in my position from here to here. It's the change in position. Or the change, if you're going up and down, this would be the change in which direction are you going as far as our axis is concerned. This is the y-axis, right? So we would call this, if I go from here, let's say I'm at -2 and I go up here to 5. Okay, if I said that that was the change in y, what would the change in y be? How do I find the change in something? So if I'm here at this one point and I got to get over here to this point right there, what is the change in that? How do I find the change in it? Yeah, okay, you could count the spaces, but let's say we don't want to sit there and put all the spaces here. What could we do to find out basically how far is it from here to here? You can do what? The difference, right, which means we do what to them? Give me a simple little math thing. What do we do? Okay, we subtract, correct? All right, so let's subtract. So if I find the change in y, I just subtract. I could go 5 minus -2, or I could go the other way. What's the other way? -2 minus 5. Now, you're going to get two different answers to that, all right? But you're still going to get the distance, okay? So 5 minus -2 is what? 7, and -2 minus 5 is -7. But when we talk about distance, we take the absolute value, and then we say it's 7. Don't worry about the absolute value thing. I'm not going to be that concerned about that. But that's the change in something. Now, I don't think I ever saw this until I got to college, but the more and more math you do, the more and more Greek letters that you use, okay? There's one Greek letter that you've used in math, especially in geometry. What was that? No, alpha, beta, not in geometry. There's one like super, we don't use sigma. In geometry, it's a letter in the Greek alphabet. Pi. Pi is a letter in the Greek alphabet that you've used a lot, okay? So you've used pi. I heard you guys say alpha and omega. I heard sigma. We use sigma in math, okay? But there's another one. I even hate to even bring this little story up, but every time I talk about this, I always tell the story, so I feel kind of obligated to tell the story. It's not much of a story, but It used to be Saturday Night Live on TV. You ever see Saturday Night Live? Yeah. It used to be funny. It's not funny anymore, but it used to be funny, and everybody would watch it. You come in. This was back before you could record TV shows, even back before we had VCRs. So we would come in on Monday, and everybody. Well, when they first started talking about it, I had no idea what it was because my parents wouldn't let me stay up and watch Saturday Night Live because it was kind of edgy and stuff like that. And my parents were like, that's not for you. You can't watch that. But all my friends would be talking about all this stuff on Saturday Night Live. Anyway, when I got older, I started watching Saturday Night Live. And it was pretty funny for a lot of years. It's kind of dumb now. But anyway, there was this one skit. It was one skit. Now, look, I'm not trying to make you laugh or anything. I'm just saying this. There was one skit where it was like a sorority. You know what a sorority is, right? A bunch of girls live in this house, right? And their sorority name was Delta, 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 right? And that was the name of their sorority. You've probably heard those before, right? Using those Greek letters. And so the girl would answer. She was like, she, no offense or anything, but she was blonde, she was kind of ditzy, or at least her character was, And she would answer the phone. Every time she'd answer the phone, she would say, Delta, 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 can I help you, help you, help you, right? And that was like a catchphrase for a really long time. People would say that. Like, you'd go to school, people would say it, Delta, 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 that kind of thing. So to me, it's funny because I remember it, and I remember kids used to say it all the time. So you could look it up. Look it up on YouTube. If you look up Delta, 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 skit, SNL, you'll probably see the skit on there. We're not going to do that in here, though. All right, anyway, so that's Delta. Delta, all that stupid story, just because Delta is a Greek letter of the alphabet, all right? And here's what a delta kind of looks like when you draw it out. It basically looks like a triangle, all right? The letter delta means the change in something. So in math, they use the letter delta to mean the change in, all right? So the rise, going up and down, the rise would be the change in what? I already wrote it down. The change in y. So a lot of times you'll see it written like this. Maybe not in a high school book. Maybe when you get to a college book, you might see it like this. And I'm sure there's a ton of high school books where they have this written. But that's the change in y. What does that mean? It means the rise. It means from one point to the other. How far is it to get from one point to the other? All right? Over the run. So what do you think the run's going to be? If the rise is the change in y, the run is the what? The change in x. That's it. All right? So you'll see in some publications, I don't know if this book does it or not. I didn't really look that closely. In some publications, you'll see it like this. They'll say, what is the slope? High school kids will say rise over run. When you get to college, a lot of people will say the change in what? Y over the change in x, okay? Or delta y over delta x. Most people would just say the change in y over the change in x. I just thought I'd throw that out there to you. So if you ever see that, like when you first get into college, like Mr. Hemrick never taught us that. Well, there it is. Now I taught it to you, okay? So that's what it means. But rise over run is perfectly fine. Now, here's where I'm getting with this. We're going to come up with a little, it's not really an equation. I guess you can call it an equation or a formula. Let's just call it a formula. I don't know if it's really a formula, but let's just do this. How did I get from one point to the other? How did I find the change in something? What did I do? What did I do with those two numbers? Give me an easy word. What did I do with those two numbers? Say it. I subtracted. That's right. Okay, so what if instead of calling this -2, let's get rid of that. Instead of calling this 5, what if I called this point y2, and what if I called this y1? All right, because it's along the y-axis. This is my first y point. This is my second y point. All right. And this is important because you're going to see this a lot when you deal with slope. So what would the change in y be? Very good. It'd be y2 minus y1. Or, do you remember it didn't matter what order we subtracted? Or I could write what? y1 minus y2. But you got to be careful. When I say it doesn't matter what order, it doesn't, as long as you subtract the x in the same order. You hear me? Okay. So if this is y2 minus y1, what's the change in x going to be? That's it. x2 minus x1. Now this is not squared. All right. We're not squaring it. That little 2 just makes it different than the 1. All right, so x2 is a different number than x1. All right, we do that a lot in math. We'll use the same letter, but they call that a subscript. They'll put a tiny number under here. That means it's the second x point, and that's the first x point, okay? That's what it means. So what would we do here, though? So if I go y1 minus y2, what do I have to? I have to subtract the x's in what order? That's it, x1 minus x2. All right, so either one of these is perfectly fine. So you can find the slope that way or that way. You'll find out that it doesn't matter which order you subtract them in, but you got to make sure you subtract the y's in the same order as you subtract the x's, okay? It's very important that you do that. All right, enough of that. I think that's enough remarks. Let's actually do an example. So this is example 1. It's in the book if you want to look, but I'll put it down right here. They actually give it to you as a graph, first of all. So let's do this. Let's grab this graph. Put it right here. Let's just make it a little bit larger so that we can see it. All right. Let's see. There. Come on. There we go. All right, so I'm going to put a couple points in here. I'm going to put the points in that they put in. So 1, 2, 3, 4. They put a point right here at that exact spot. And then they put a point, 1, 2, 3, 4. They put a point right there. And we've talked about slope in the other chapter. I think it was the other chapter. Oops. Let's try to get this to not scooch over. Anyway, it's close enough. All right, so what we want to do is we want to find the slope of this thing. How steep it is. All right, everybody watching? So I want to find out how steep that line is. I'm not looking for how long the line is. Okay, I'm just looking for how steep the line is. I'm not looking for the midpoint. We just did that, didn't we? All right, so I'm not looking for the midpoint. I'm looking to see how steep the line is. All right, I'm not looking for the midpoint. A lot of people get confused because these problems kind of look the same because they're going to give you 2 points. They're going to ask you different questions. One question is, what's the midpoint between those 2 points? Another question is, what's the slope between those 2 points? Then we're going to do something later on. I don't think we've done it yet. Have we done distance formula? I don't think we've done that in here. I did it in my other class. And then we're going to find the distance between 2 points. So they're going to ask you 3 completely different things, but it kind of looks like it's the same question because all they give you are 2 points. Everybody understand that? All right, so right now, if they give you 2 points, you should be able to find the midpoint. Just took a quiz on it. And now they're going to give you 2 points, and we're going to find the slope, how steep the thing is. Thought you were going to ask me a real question. All right, so what we're going to do is how steep this is. Now, from left and right, what does this thing do? Does it go up or down? It goes down, right? From left to right, it goes down. We're going down the hill. So what's the sign of my answer? Before I do any work at all, I can just look at this thing and know what the sign's going to be. What's the sign going to be? It's going to be negative. That's right. So from left to right, if it goes down, that's a negative slope. Everybody got it? All right. So now what we need to do is we need to do the rise over the run. So if it's something like this, if it's simple and it's on a graph paper like this, we could just count if we wanted to. Let's do that. Now, that's not the way that we're going to do these problems, but we could if we wanted to. So let's make this a little bit thicker so it shows up. All right, so I could do the rise over the run. So let's start at the top one, and I'm going to rise. How far do I go? All the way down to there. Everybody see that? And then how far do I run? I run, yeah, we'll count in a second. All right, then I run this direction. Everybody see that? That's my rise. Let's change this back, okay? So this is my rise. Now, when I say rise, we always think of going what? Going up. But in math, rise could be going up or it could be what? Going down, okay? So if it goes down, it's a negative rise. You go up, it's a what? Positive rise. What about running? If I run to the right in math, that's what direction? To the positive direction. And if I run to the left, that's what? The negative direction, okay? So what we do is we started here, and then I got to figure out the rise. So I count 1, 2, 3, 4, 5, 6, 7, 8. It's not just 8. We went down, so it's what? So it's negative 8. So the rise is negative 8. Now we're here. Okay? You don't really need to put a dot there. I just filled it in. And now we got to run. So we're going to go to the right. How many places? 1, 2, 3, 4, 5. What's that? Positive 5. So what is my slope then? My slope is negative 8, which is the rise, over what? The run, which is positive 5. Now, when it's negative, you could, watch this. I could have gone the other direction. Let's do this in a different color. Thank you. I could have started at the bottom. I just want to show you that you're going to get the same slope, same exact slope. Doesn't matter if you go from the top to the bottom or from the bottom to the top. So if I'm here, I got to go up to here. Everybody see that? And then from here, I got to go this way. Now we went two completely different directions. On the other one, we went down and we went to the right. On this one, we go up and we're going to the left. But we're still going to get the same slope.
We put the negative just like right.
That's what I'm going to show you. That's what I'm getting to. I'm getting to that in a second, because I know exactly what you're going to say. Now, what's the rise over here? If I started here and I went up, it's a positive 8, correct? Over. And then if I'm here and I go this way, what's that? That's a negative 5. Is negative 8 over 5 the same thing as positive 8 over negative 5? Absolutely it is, okay? For instance, if I had negative 12 over 3, is that the same thing? Put a question mark here. Is that the same thing as 12 over negative 3? Sure it is, because what's negative 12 over 3? It's negative 4, isn't it? What's 12 over negative 3? It's also negative 4, okay? Doesn't matter if the negative's on the top or the bottom, or we could put the negative where? Yep, right out front, like this, okay? Either one of these, up here. See, I heard somebody knocking on the door, right? And I wasn't distracted, right? I can just keep going. I don't know why you can't. So look, negative 8 over positive 5 is the same thing as positive 8 over negative 5, which is the same thing as just having the negative right in the middle, all right? Either one of those means the same exact thing. A lot of people get mixed up on that. I don't know why. They just weren't taught in Algebra 1, I guess. All right, so I'm teaching it to you now. So either way, this one, or this one, it means the exact same thing. So it doesn't matter if you start at the top one and go to the bottom one, or if you start at the bottom one and then go up to the top one. You're still going to get the same exact answer. Agreed? Okay. You could do it another way. And this is the way that we're going to do it, okay? This would be a pain. Every time they give you 2 points, do you want to have to graph those 2 points and then count? What if they give you like a point, negative 3,452, and then another point? I'm not going to graph that. That'd be ridiculous, okay? So I need a method. I need a way to do this, and that's what we talked about right up here, all right? So let's write down what the 2 points were. What's that point and what's that point? I know I got a lot of junk on here, but what is that point up top here? It's negative 2, what? 1, 2, 3, 4. So it's negative 2, positive 4. So most of the time, they probably won't give you a graph. Most of the time, they're just going to give you 2 points. They're going to ask you to find the slope, okay? They're going to do a variety of different things, but this is like one of the common things. What's this point down here going to be? So it's, now you go to the right and then down. So it's 1, 2, 3, and then 1, 2, 3, 4, okay? So it's positive 3, negative 4. So it's 3, negative 4. So here's what most of your homework is going to be. They're just going to give you 2 points, and they're going to ask you to find the what? Find the slope between those 2 points, okay? They're going to say find the slope, and they're going to give you 2 points, okay? Do you have to graph it to find the slope? Absolutely not. It'd be a pain in the butt. That'd be way too much work. It's way easier doing it like this. So what is our little formula? The slope is rise over run, or what? Change in y over change in x. How do I find the change in y? I can't hear you. Yeah, just subtract the y's from each other. You could go y2 minus y1, which most books do for some reason. And then you could go what? X2 minus x1. Now, where are those points? Where's my x1, my y1? Where's my x2 and my y2? Well, it's these 2 points. So if I called this my first point, this would be my x1, and this one would be my y1. If this is my second point, this would be my what? X2, and this would be my y2. Okay? You just got to understand what this means. It's really simple once you get going on it, okay? You don't have to write all that stuff in there. It's just you take the x's, you subtract them, you take the y's, and you subtract them. You just got to make sure you subtract them in the same order. It's really important that you do that, okay? So let's subtract the y's. So let's go y2 minus y1. So y2 is negative 4 minus y1, which is positive 4, right? I was looking at the x. So there's my y2 minus y1. Write it down. Some of you guys aren't writing anything down. You should write this down. Negative 4 minus 4. That's the change in y. Okay? If you look at it, it makes sense. Where are we on the y-axis right here? We're at negative 4, aren't we? Where are we up here on the y-axis? We're at positive 4. How do you find that change? You subtract, right? See how it all comes together? Now, what about the x's? Well, you just subtract the x's from each other, but you got to subtract them in the same order. So if I went the second one minus the first one, I got to do the same thing with the x. I have to, or I'm going to get a wrong sign, all right? And you won't get it right. Even if you miss a negative on this, you're going to get it wrong. So let's go x2 minus x1. So x2 is 3 minus, it's not just minus 2. What are we subtracting? Minus a negative 2. That's right. Minus 2. Or, yeah, minus 2. Okay? So that's the key right there, setting it up. It's very, very simple. Again, I'm talking way too much about it. It's just so easy. You just subtract the y's, put it on top. You subtract the x's, put it on the bottom. And then you just simplify. It's as easy as that. So now let's do that subtraction on the top. Negative 4 minus 8. What's negative 4? I gave it away. Negative 4 minus 4 is negative 8. What's 3 minus negative 2? It's positive 5. Does that look familiar to you? Absolutely. So we could do it so much easier just with this little midpoint formula than we did with the graphing, all right? But the example actually gave the graph. You had to figure out the points, and then you had to go through all this stuff, all right? Let me, all right. So that's how you do that. I'll tell you what, let's do one real quick. We got some time. So, I don't know, does anybody have their book? Anybody got their book open or anything? Nobody? Well, you got a digital book, right? No, I'll just make one up. So, I don't know, give me an ordered pair. Not super big numbers. Give me reasonable numbers. 8 and 7. Okay. And give me another one. Give me some negatives. Negative 6 and 5. Okay. All right, so I want to find the slope of this. Do I have to graph it and then count down and count over? No. I can just use my little formula. So the slope is the change in y over the change in x. All right, I'll say that a lot. The change in y means we subtract the y's from each other. It does not matter what order we subtract the y's as long as you subtract the x's in the what? In the same order. Everybody hear me? I've said it like 3 times today already. All right, I'm going to say it more. So we subtract the x's, or subtract the y's, because it's rise over run. And I'll tell you what, I hate to even say this because it might stick this in your head and you might make this mistake. But a lot of students, they think x, y. Well, x goes first, y goes second, so x must be on the top. But is that slope? No. It's rise, which is the y, right, over the run, which is the x. Always think rise over run, y over x. Change in y over change in x. I can't emphasize that too much. I've seen so many students in the past mix that up and put the x's on the top. You had a question? You good? Okay. So let's subtract the y's. It doesn't matter which order we subtract them in. I could go the second minus the first or the first minus the second. Let's go the first minus the second on this one, just for fun, okay? So what would that be? 7 minus 5. Let's do the x's. The x would be what? X, it's not minus 6. What is it? X minus negative 6, because that's a negative, and we subtract. And now we just do it. That's 2 over, what's that? 14. Am I going to leave it like that, though? We've got to reduce it. Always reduce your fractions. So what's the slope between these 2 points right here? It's 1/7. And that's it. That's how you find the slope. It's really, really simple. Yes, it's always going to be a fraction, even if it comes out even. Like if it came out like 8 divided by 4, okay, that's going to be what? 2. Now, you could just say the slope is 2. That's fine. But you could always say it's 2 over 1 if you wanted to. All right? Everybody with me? We never, ever, at least in high school, will never write the slope. Well, I shouldn't say that. We rarely write the slope as a decimal. Okay? Now, they may give you a problem where they actually put decimals in there, and we might come out with a decimal for a slope. All right? But if they just give you regular integer type numbers, almost all the time, we're going to write it as a fraction. Okay? All right, got a few more minutes, so let's go to the next thing. Would you agree? Finding slope's pretty easy? But you got to keep that straight between finding the midpoint and finding the slope. How do I find the midpoint between 2 points? I take the x's and I do what to them? I don't subtract them, I do what? I add them and then divide by 2. We just took a quiz on it yesterday. All right, we forgot it already? All right, so let's do the second example and we'll be finished after this example. Here's example 2. It says find the slope. But look, they don't just give you 2 points this time. They're going to give you an equation of a line. We have done equation of a line. Y equals mx plus b? Yes? We've done that in here, correct? Yeah. All right. So what I want to do is I want to find the slope of this. Now, what if, don't write this down, what if they gave you that as your equation? What's the slope of this equation right here? It's just 2 over 5. I don't have to do any work at all, right? I just look at it. I know y equals mx plus b. Remember, m is the slope. So the slope is just 2/5. So what I'm going to do, is this written like this? No. So what do I need to do to this to make it look like this form right here? This is called slope-intercept form. This right here is called, what do we call that? We did this. Didn't we do this earlier? We call it standard form. Do you remember that? Okay, this is standard form. This is slope-intercept form. So what I want to do, I want to change this to slope-intercept form. So Alex, what am I going to do? Okay, what's my final goal, though? Very good. Okay, we need to get the y by itself. Now, Alex, go ahead. What are we going to do? Subtract a 3x from both sides. Now, watch very carefully. Write this down. Okay, if you're not writing it down, and if you're just sitting there watching, you're not going to remember this. All right, so write it down. You should be writing down everything that I've been writing down up to this point anyway. So what I'm going to do is subtract a 3x from both sides. I believe that we've done this already. All right, we have changed from standard form to slope-intercept form already. So this shouldn't be new. All right, so I'm going to subtract a 3x. I'm going to do a little bit of this in my head. Still showing my steps, but I'm going to do a little bit in my head. I'm going to subtract a 3x, so you know what happens when I subtract a 3x. Cancels out, right? And then I'm going to subtract a 3x from the other side. But do I want to go 12 minus 3x? No, because I want the x to be first before the regular number. So I'm not going to go 12 minus 3x. I'm going to go negative 3x plus 12. See what I did? I subtracted a 3x, and then I subtracted a 3x from here. I just put it out in front. That's all I did, okay, instead of behind the 12. Okay, we good with that? Yeah, we've talked about that before. Alex, one more step. What do we do? Divide by negative 4. So I divide this by negative 4, and you got to be careful. You got to make sure you divide everything on the right side by negative 4. So divide that by negative 4, and you divide that by negative 4 as well. You writing it down? That cancels. Y equals, What's this? It's negative 3 over negative 4. What's negative over negative? It's positive 3/4 what? X. And then what's this going to be? Not plus 3, because this is a negative. It's going to be minus 3. Plus a negative, but we'll write it as negative. What does the question say? The question says find what? Just the slope. That's all you need to do is just find the slope. So now it's kind of like this one, right? Where it's really easy just to look at it and see what the slope is. So what is the slope? It's 3 over 4. There it is right there. It's just sitting right there in front of you. Remember, y, let's do it. Let's put it up top here. Y equals mx plus b. Okay? And all they're asking for is to find the slope. Because that's what this little lesson's about. It's just about finding the slope. We good? All right. So, let's see. I wrote down, it should be on your lesson plan thing. Let's see what it is. 17 to 38. So it's section 2.2. We're going to call it part A because there's more that we're going to do with this. So section 2.2A, and it's pages, what, 109, 110. So it's pages 109, 110. Whoops, not 1,000. Number 17 to 38.
And just a reminder, high school chapel team, you had practice at lunch today in the sanctuary. Thank you.
All right, there's your homework. This is due tomorrow. It shouldn't take you that long at all. It should be pretty easy. Once you do a few of these, you'll really get the hang of it. Just subtract the y's, subtract the x's, simplify your fraction, and that's basically what you're doing for the whole entire homework. Yeah. Yeah, if you're not here, you turn it in the next day that you show up.